This is activity number 3 for lesson B-17. For this activity, you will need the assembled Raspberry Pi setup from previous activities, the assembled circuit from the last activity, 6 long male to female jumper wires, and the capacitive touch sensor. In this activity, you will add the capacitive touch sensor to the circuit from activity number 2 and create a program that will use the input from touchpads 1 through 3 to control the red, green, and blue elements of the RGB LED. Since we're going to start this activity by making modifications to the circuit, shut down the Pi and disconnect power before proceeding. Once the shutdown is complete, remove the capacitor experimentation circuit from your breadboard. This includes the long jumper wire connected to GPIO 20. When completed, your breadboard should look like this. Next, add the capacitive touch sensor using the male to female jumper wires. Make each of these connections one at a time to avoid connecting anything improperly. Here are the 6 connections. VCC to breadboard connection C9. Ground to breadboard connection C5. Out 4 to breadboard connection C4. Out 3 to breadboard connection C6. Out 2 to breadboard connection C7. Out 1 to breadboard connection C8. The capacitive touch sensor is now connected, and pads 1 through 4 can be used to trigger inputs connected to GPIO 22, GPIO 27, GPIO 17, and GPIO 4. You will now create a program that will use pads 1 through 3 to control the RGB elements connected to GPIO 13, GPIO 19, and GPIO 26. Power on your Raspberry Pi and open Thonny. Create a new program called cap_touch.py and save it to the desktop. This program will interact with GPIO pins and will use a time.sleep delay, so the RPi GPIO and time modules need to be imported. Next, the GPIO pins connected to the touchpad will need to be configured as active high inputs. Software pull-down is required, and the GPIO pins connected to the RGB LED will need to be configured as outputs. To make this task easier, use some lists to hold the pin information so setup can be completed in 2 lines instead of 6. Use a variable named pads to hold 22, 27, 17, and a variable named RGB to hold 13, 19, 26. Set the pin mode to BCM and this list to configure the inputs and outputs. Add a try except loop to catch keyboard exceptions and run a GPIO cleanup. Also, add a while true to the try block so the main program block will keep looping. Now the main program will need to check each of the pads, and if they've gone high, indicating they've been touched, turn on an element of the RGB LED. Here's the mapping for the inputs and outputs. Input GPIO 22, output GPIO 13, RGB color red. Input GPIO 27, output GPIO 19, RGB color green. Input GPIO 17, output GPIO 26, RGB color blue. The first one, for example, means that touching the pad connected to GPIO 22 should push GPIO 13 high, turning on the red element of the RGB LED. You can use while loops to keep each element high as long as the corresponding touchpad is activated. Each touchpad and RGB element combination will need its own while loop. Each LED will now turn on when its corresponding touchpad is activated, but there is a problem. They'll never turn back off. You can turn all the LED elements off at once by using the RGB list that you created at the beginning of the program. Set the list of pins low using RGB and add a time.sleep of 0.1 to slow the main loop down so the touchpads aren't being checked 1,000 times per second. Go ahead and run the program and touch each touchpad 1 through 3. Touching the pad will make an RGB element turn on, and releasing the pad will make the RGB element turn off. If your program does not work as expected, confirm your code matches mine. Save the program and leave the circuit assembled so you can use the circuit in the next lesson. Once you're ready, move on to lesson B-18, where you'll work on the final project for this level of the Intro to Robotics course.